Tom Wessels is a terrestrial ecologist and professor emeritus at Antioch University, New England, where he founded the master's degree program in conservation biology. With interests in forest, desert, Arctic, and alpine ecosystems, plus geomorphology, evolutionary ecology, complex systems science, and the interface of landscape and culture, Tom considers himself a generalist. He's conducted workshops in ecology and sustainability throughout the country for over 3 decades. He's also the author of numerous books, with his latest being Granite, Fire, and Fog, The Natural and Cultural History of Acadia. And I must also mention The Myth of Progress Towards a Sustainable Future. It is very fitting the way that Zainab set the stage for Tom. Please welcome Tom Wessels. Tom.
Thank you very much, and I just want to say that was a terrific story. Right on, and that really does sort of encapsulate, as an example, what I'm going to talk about is, when I start my Principles of Sustainability class, the first thing I tell my students is that at its core, sustainability and a sustainable future is all about right relationship and building robust networks of relationships that are mutually beneficial. And I think that Zainab's story points that out. It's that power of that relationality that's going to get us where we need to go. Tons of studies have shown that as we increase energy efficiency technologies, in a country like this, our per capita use of energy doesn't go down, it goes up. Because, again, technologies are a tool that can help us, but on their own are not the solution. The solution is really people and values and connections. So I'm going to talk about, I guess, this whole notion of relationality from a scientific perspective. The bulk of this talk is going to be on the principle of self-organization. But what I'd like to do is start a little bit with talking about the principle of nestedness, limits to growth, and the second law of thermodynamics, because they sort of set the stage for actually why we're here today. And then self-organization offers a wonderful model of how to create these robust networks of mutually beneficial relationships. So all systems are nested one within another. So for example, our cells are nested in our organs are nested in our bodies are nested in communities, which are nested in ecosystems, which is nested in the biosphere. It's just a reality that there's all this nestedness that's happening, and because of that, that predicates limits to growth, that no system can keep growing. Because let's say if a system that is embedded with another system keeps growing and starts extracting energy and materials at rates that are higher than replenishment rates, that larger system becomes degraded and becomes entropic. And entropy is a process that as a system loses energy, it moves from a state of order to disorder. Now, I don't like those terms because I think order and disorder are really very subjective things. I used to teach at the Putney School. It's an independent secondary boarding school up in Putney, Vermont. And for about 6 years, I was a dorm head of a girls' dorm. And every Sunday, we would have sort of room inspections to try to encourage students to keep their rooms somewhat organized. And I can assure you, their idea of order and my idea of order was really, really different. So, so a much more sort of objective way to measure entropy is that as systems move into entropy, they always move from a state of complexity towards simplicity and a state of concentration of energy and materials toward a state of diffusion. So imagine a tree getting knocked over in a wind event, like one of those nor'easters we had recently. It gets uprooted, it dies. Well, that tree has become entropic. As decomposing organisms move into it and start decomposing it, extracting the tree's energy, the complex structure of that tree starts to become simplified. And its complex molecules like cellulose and lignin get broken down to simple molecules like water and carbon dioxide that diffuse out into the atmosphere. And then after a number of decades, that tree is gone. That's the ultimate sort of entropic state. It's completely simplified to very simple molecules that diffuse out, and that's it. So this is the situation. If you start extracting energy from a larger nested system at rates that are greater than replacement, it becomes entropic, and it moves towards simplicity, and it moves towards diffusion. Pretty much every single environmental problem we're looking at today is an entropic problem, and certainly climate change is one, where we've taken concentrated storage of carbon and diffuse them into the atmosphere. And now we're going to get a lot of other entropic results because of that. These will be secondary to the original diffusion of the CO2. There's going to be a lot of other things that are going to happen as well, as you're going to hear about more throughout the day. So that sort of sets the stage for why we're here. As a collective human community, we are now releasing more energy out to space from our transformations that's being replaced to the biosphere through photosynthetic gain. And as a result, our ecosystems are becoming simplified, energy and materials are diffusing. So if we're ever going to turn this around, we've got to find ways to really collectively bring down our consumption levels, and I personally believe this is by establishing more robust relational work. That I think that can displace sort of our, at least in our culture, this sort of need to consume. So with that, I want to move on to the principle of self-organization, because I think this one is a really good model that we ought to be incorporating in everything we do in our human systems, whether it's our families, whether it's communities, whether it's businesses, whether it's an economy, whether it's a political system. It really doesn't matter what scale we're looking at. So what self-organization is, and I should mention, this is a principle fairly new to Western science. Western scientists only came across self-organization about 50 years ago. And yet, I am sure it was well understood way, way long ago by indigenous people and people of different cultures around the globe. And probably Western scientists were probably the last people to actually stumble across it, which is too bad because it's really something good to really understand. So what brought it about in Western science is near the end of the 19th century, as we moved into the early part of the 20th century, there were researchers in all sorts of different disciplines, people in sociology, anthropology, cybernetics, ecology, biology, psychology, who were finding that the linear reductionistic approach of Western scientific research was not helping them understand their subject areas. And so right after World War II, some conventions were organized in New York City that brought research from all these different sort of disciplines together just to talk about what they were seeing in their chosen fields. And they all started to realize they're seeing the same things. They're seeing feedback loops. They were seeing emergent properties. They were seeing bifurcation events. And what this gave rise to was sort of a unified body of theory called complex system science or complex systems theory. And one of the principles within that was the principle of self-organization. So what self-organization is, as a system is growing, if it self-organizes, it doesn't just get bigger, it gets more complex. And that complexity is derived from the parts within the system through time becoming ever more specialized and tightly integrated together in networks such that each part doing what it needs to do to sustain itself creates conditions that sustain the whole. And as a result, these self-organizing systems grow more stable, more resilient, and more energy efficient. So I'll go through that one more time because that's a lot. But a process that as a system grows, it not only gets bigger, it gets more complex. The complexity derived from the parts becoming more specialized and tightly integrated together, such that each part doing what it needs to do to sustain itself creates conditions that sustain the whole. And as a result, these self-organizing systems grow increasingly stable, resilient, and energy efficient. So our bodies are a perfect example of this. All of us in this room started life as a single microscopic cell. And yet today, our bodies hold about 40 trillion of our cells, and probably another 100 trillion of other cells that aren't ours. There are things like fungi and bacteria and other things like that. And so our bodies actually are an ecosystem that, is often not thought of, but that's what we are. But during our developmental phase, that one cell of ours didn't just multiply to 40 trillion. The cells started differentiating and specializing. So now we have 254 different cell types in our bodies, bone cells, skin cells, muscle cells, nerve cells, but the specialization in the cells goes even further. Some neurons just connect to sensory cells. Other neurons just connect to motor cells. Other neurons connect sensory neurons to motor neurons. Our cells are really, really specialized, but luckily for us, they're tightly integrated, with each cell doing what it needs to do for its own purposes, creating conditions that make us stable and resilient. So in terms of stability, you go into our internal bodily environment, temperature right at 98.6, pH right at 6.8, blood sugar levels carefully controlled, CO2 levels carefully controlled, everything very stable, and we're resilient. If we get wounded or we get sick, we heal. And that's all because we're great examples of self-organization. But being an ecologist, I like looking at this process, how it plays out in ecosystems through evolutionary time, through the process of coevolution. Now, out in ecosystems, the bottom line currency is energy. And energy currency is a rock-hard currency. A kilocalorie of energy is always a kilocalorie of energy, and it's finite out there. There's only so much of it. So nature is always urging organisms to develop strategies or adaptations that make them more energy efficient. Because if they are successful, it means they can support a larger population on the same finite amount of energy. So nature's always urging species to move towards energy efficiency. It's culling out organisms that are energy inefficient. And this is the driver of coevolution. And as you're going to see, what coevolution does is create this robust network of these mutually beneficial relationships. Now, for a good while now, ecologists have been trying to teach people that we shouldn't be taking organisms from one part of the world and bringing them into another part of the world. Because what we do is we create all sorts of very young ecological interactions. And those species have had no time to adjust their ecologies to have these more energy efficient and more beneficial relationships. So these young ecological interactions are usually harmful for one or more parties. So a great example of this was the accidental introduction of the chestnut blight fungus into the Bronx Zoo and Botanic Garden in 1904, where they were planting oriental chestnuts. Now, don't ever do this if you meet someone that works down at the Bronx Zoo and Botanic Garden. I made a big mistake. I mentioned this, and it's still something they're really sensitive about down there. So just don't say anything if you happen to be down there. But to their credit, that fungus and those old world chestnuts had co-evolved to such a degree that they couldn't even tell they were infected with anything. They didn't even have lesions or anything like that. But the American chestnut and that fungus had never interacted. And at the time of that introduction in 1904, it's believed the American chestnut was the most common forest tree east of the Mississippi River. In the heart of its range, places like Tennessee and Kentucky, records show that about 1 out of every 2 forest trees was an American chestnut, and they grew to immense size. We have pre-blight photographs of chestnuts up to 18 feet in diameter, 14 feet in diameter. So that screen's about 12 feet in diameter, in width. So imagine a tree that's about another 2 feet wider. They could grow up to close to 200 feet in height. They produced the most edible nut of any tree in North America. They were truly the signature tree of the temperate deciduous forest in North America. And it only took about 30 years for that fungus to escape from the Bronx Zoo and Botanic Garden and almost completely annihilate the species. So obviously, a very bad outcome for the American chestnut and a very bad outcome for our forest ecosystems, because we really don't know how much they've changed with the demise of the chestnut. But I'd like you to contemplate the fungus. If you're a host-specific parasite, the very worst thing you could do is to eradicate your host species. Because if you do that, you've just eradicated your own species. That was a really terrible thing for that fungus to do, and a really energy inefficient thing. It would have been so much better served if it didn't kill off its host tree. It would have lived longer, it would have reproduced more, there'd be more of a resource for its offspring. It did just about the very worst thing it could do. But if 2 species make it through that initial contact without extinguishing each other, natural selection kicks into gear and starts urging them to change the nature of the relationship to become more energy efficient. And with that, the relationships become more beneficial. Now, I should mention, I'm confident the American chestnut's going to come back. 6 years ago, in the very southwest corner of the state, on Mount Everett, graduate students and myself encountered 2 stands of reproducing American chestnuts. Each stand was probably about 100 acres in size. They were both embedded in a big block of old-growth forest down there. And these trees had the ability to encapsulate that fungus in cankers. And they were making it up to about 16 inches in diameter, but big enough to be reproductive for probably about 40 years or so. And all in the understory were seedlings of American chestnuts and pole-sized trees. And my guess is those seedlings will have a higher level of resistance, and maybe they'll make it up to 20 inches before they succumb. And maybe their offspring will make it up to 30 inches. And after a number of generations, we should find we have really resistant chestnuts. And I imagine there's more stands like this out there. So right now, Coevolution is working its wonders in working to have these 2 species improve the quality of their relationship. Now, my favorite example of how Coevolution can do this is you can start right off with something like a predation, what that fungus was doing to American chestnuts, and it can co-evolve all the way up to a mutualism where both parties not only benefit, but have to interact to benefit. And so my favorite example of this involves 2 species that aren't around here. They're down in Central America. But one of the species is the bull's horn acacia tree, and the other is its resident Azteca acacia ant. And through their co-evolved time together, the acacia tree has developed 3 features to service its ants. The first is the thorns that used to ward off herbivores have become really huge and pliable and swollen, and they don't protect the tree anymore, but the ants drill into them, hollow the thorns out, and then that's where they raise their young. Secondly, on every leaf stem are these open nectaries or sap wells where the sap just comes out of the stem and the ants go and drink it, and that's where they get their carbohydrate energy resource. And then finally, around the margins of every leaflet are these little globules called Belchian bodies, and the ants harvest them for the nutrition, and then they grow back. Through their co-evolved time together, the ants have become so specialized on the acacia, they can only eat acacia sap and Belchian bodies. And if they're removed from a tree, and even given all sorts of other food items, they'll starve within about a day's time. But in return, they give their host trees the most advanced plant defense system in the world. They have a very venomous sting that will ward off all herbivores, so these trees never get munched on at all. But not only that, if vines try to crawl up an acacia tree, the ants will come over and they'll chop those vines down and kill them. If a surrounding tree starts to move in the acacia's space, the ants will go down off their tree into that surrounding tree and defoliate it. If you remove the acacia ants from their host tree, it'll be dead in about a month's time. But what's wonderful about this example is we know from the mandibular structure of these ants that they're derived from leafcutter ants. So way back whenever the ancestral leafcutter ant and the ancestral acacia first came together in a young ecological interaction, was probably not a very pretty scene. Trees might have been being stripped of their leaves and killed, a very energy inefficient thing to do, and somehow natural selection urged them into this current mutualism where they both have to interact to survive. So that's sort of the way it works. Now, if we were to look at, let's say, competition, that's another ecological interaction. In nature, competition between different organisms is an energy inefficient thing to do. They're losing energy in their competitive struggles. So what nature does is it kicks into gear, urges them to change their ecologies so they can coexist without competing. And this is through what's called niche separation. So a species niche is its total ecological role. So it's a very hard thing to get a handle on. So ecologists break it down. We might talk about the foraging niche, like how does this bird go about finding and securing its food? That would be its foraging niche. So species can separate their niches in many ways. They can do it through what's called temporal separation, where all of a sudden they adjust the time that they're active. So we get owls active at night and hawks active during the day, and in this way they do not compete. This can even happen in the plant world. So In about another few weeks, it's hard to believe right now, but in another few weeks, if we go out into our calcium-enriched woodlands around here, we'll be able to walk into those forests, and before the canopy leaves have broken out, we'll be able to see a completely green emerald carpet covering the ground. And that will be from the leaves of wild leeks and Dutchman's breeches and squirrel corn and trout lilies and spring beauties. And I should mention, all 5 of those wildflowers are called vernal ephemerals. They grow up in the month of April. They do all their photosynthesis before the canopy leaves come on. Then they die back down below ground level in early May, and a whole new cohort of plants comes up in the understory, like baneberry and blue cohosh and Virginia waterleaf and things like that. And because that we have these 2 groups of plants that have temporally separated their niches, we get the most species-rich understories in these woodlands, because they figured out how to coexist without competing at all for light. Now, another way species can separate their niches is through what's called microhabitat separation. We could probably actually see this right down here in Cambridge, where we could find probably chickadees foraging for insects on branches, and white-breasted nuthatches foraging for insects on the trunks of the trees. They can be going after the same type of insects at the same time, but they don't compete because they've specialized on what part of the tree they're going to work with. And then finally, down in the Galapagos Islands, this can be done through what's called resource partitioning, where you can get these mixed flocks of different finches, and the large big finch will only eat large seeds, the small big finch will only eat small seeds, and in this way they can coexist without competing. But as you're going to see, in all these examples, they're becoming more specialized. And what that means is their niches, their ecological roles are getting smaller, which means through time, ecosystems can start supporting more and more and more species. So if we were to go out, let's say, in a meadow around here, and we wanted to clock all the different insect pollinators throughout the whole blooming season, from early May all the way through to November, we'd be able to find well over 1,000 different insect pollinators. They all can coexist because they are specialized in different ways, active at different times of day or night, different times of the season, working in different ways. And what this does, it builds up an incredible repetition of function. And that is the key to the resiliency of these systems and the stability. Every critical role we look at out in the natural world, we don't just have one species doing it. We've got hundreds to thousands of species doing it. So when look at decomposing fungi, we've got thousands and thousands and thousands of species of decomposing fungi, over 1,000 insect pollinators. In terms of photosynthesizing plants in ecosystems around here, hundreds of them. And what that means is if any one species should go extinct, the system's fine. Because we have all these other players doing the exact same functional role. So the way this coevolutionary process works, energy efficiency is driving it. It's causing species to adjust their ecologies by specializing. Remember, in self-organization, the parts become more specialized, which allows the niches to shrink, which means more and more species can be supported in the ecosystem, which builds up the repetition of function, the stability, and everything else, the resiliency that goes with it. So it's a really, really wonderful model we should be thinking about. Is this making sense of how this is working? All right, good. So, like I said, we can apply this to our human systems. And one of the problems we really have to address when we're not just looking at climate change, we're looking at any sort of environmental issue, is we've got to bring down our consumptive levels, particularly of energy. We've really got to bring down our energy consumption levels. And there's tons of ways to do that. There's lots. But that means we're going to be working at different scales, at different ways, all at the same time. So we can work personally on our own personal choices. We can work in our families. We can work in our communities. We can work at the level of states, countries, whatever else. We're going to have to be working on all this different stuff. But one thing I really believe we have to do is we have to restructure our socioeconomic system to be far more self-organized. I think that this is the key. If we're ever going to have success in turning things around, we've got to restructure the way we do things into a much more self-organized way. So for example, just like the economy today, if you look at any sector in our economy, I don't care if it's retail or financial or energy or pharmaceuticals or agriculture or media, it really doesn't matter what sector you look at, you're going to find that the bulk of the capital is running through a handful of very, very large corporate entities. Now that's sort of a radical shift. You know, if we were going to look at economies going back, 100 or more years, that wouldn't have been the case. I remember growing up as a young child, the only big store I remember in our community growing up was a grocery store. I think it was an A&P grocery store. But all the other stores were specialized stores. If you're going to get clothes, you went to a clothing store. If you're going to get your pharmaceuticals, you went to a pharmacy. If you were going to go and get shoes, you went to a shoe store. And these were all local, small businesses, many of them in our town, that had figured out how to sort of coexist without competing. But that's changed really dramatically. We've seen incredible consolidation and concentration into fewer and fewer economic entities. So self-organization at its core is a process that decentralizes critical functional roles to build up resiliency and build up stability. And our socioeconomic system's gone the other way, where we've moved towards concentration to fewer and fewer and larger entities. Now, what's been able to drive that process are two economically inexpensive and flexible energy resources in the form of petroleum and electricity. Because what those two things allowed us to do was to start to mechanize. And mechanization allowed for the building of these very large corporate entities. Because when you're looking at an economy, economic efficiency is based on how much output can be produced for each unit of human input or labor. So if you can get big enough to mechanize, you can actually get more output with less human labor, and that boosts your economic efficiency. But the problem is, it dramatically lowers your energy efficiency. And there's a big cost there, because what it means is as we get bigger and bigger and bigger and more concentrated, we not only lose resiliency and stability, but we start becoming more and more energy inefficient. So let me just give you an example of this. One of my former students who loved to brew beer, and he loved to compost, and he loved to grow his own vegetables, after he graduated with master's, decided, well, I guess I'm not going to pursue solid waste management, which was what he was studying. He says, I want to follow my passion. I want to make beer, I want to grow vegetables, I want to compost. So he started a restaurant in Greenfield, Massachusetts called the People's Pint. Yes. If you're ever over that way, yes, make sure you stop there. And if you can ride your bike, it's even better. You'll get a 10% discount on your meal. Now, I should say that Alden, who started this restaurant, he started it because Greenfield needed a place where people could just gather, a social place. And he allows that restaurant to be used by community organizations for free, for social gatherings and stuff, and all sorts of things. So it's such a successful model that people have come to him and said, come on, Alden, can you start another one of these over in North Adams, Mass? Or can you start one here? And he goes, no, that's not the model at all. You start your own one. Be independent of me, I'll help you figure it out, but what we need is a lot more independent restaurants like this instead of a chain that just grows and gets bigger. He says, I'm not growing at all. I'm capped the size of my restaurant, that's it, that's what I want to do. And if you go there, they serve, a lot of organic meals and vegetarian meals, and they'll have fish and chicken, but there's only one beef entree, and that's a cheeseburger or a hamburger. And that beef is grown by a friend of his who just grows organic grass-fed steers about 10 miles away in this farm from Greenfield. So I'm not going to even go into the energetics about growing those grass-fed cows to produce meat compared to our industrial model, which puts them in feedlots and fills them up with grain that's grown in other areas and everything else. I'm not even going to go into the energetics of that. I just want you to think about the amount of embedded energy in getting that hamburger meat to the People's Pint well, I guess the slaughtering of the animals, processing the meat, getting it to the people's pint, and having it made into hamburger patties. There's a certain amount of embedded energy that has to go in that process. But then I want you to contrast that with the largest hamburger maker in the world, which is McDonald's. And I want you to think about how much embedded energy is there in each of those McDonald's hamburger patties. Because their beef is sourced from around the world. Some of those steers can travel thousands of miles to slaughterhouses. There's a bunch of embedded energy in moving those animals around. In those slaughterhouses, it's pretty much all done by mechanization. So you have all these machines that are using energy to drive them. But not only that, what's often hidden from view is all the embedded energy in the machines themselves. How much energy did it take to extract the materials out of the ground, to refine those materials, to build the parts, to build the machines, to ship that stuff and everything. There's incredible amounts of embedded energy there in all that mechanization. So you got that. So then the cows are slaughtered. Their meat is ground by machines. It is made into patties by machines. It is boxed by machines in boxes that are frozen. And then those frozen boxes are shipped hundreds and hundreds of miles to distribution centers. And then from there, they're put in trucks and shipped to the retail outlets. And if you're really going to look at the energetics of it, for every pound of hamburger that's served in, hamburgers or cheeseburgers, the people pint, compared to those of McDonald's, and I haven't even gotten into the energy of raising those steers in each sort of model, the ones from McDonald's is going to be way, way, way higher in its energy embedded within it. And because of that, you have all that exacerbated entropic cost and all that exacerbated environmental impact because of the mechanization. So I think that self-organization is a great model for relocalizing. I'm not saying we get rid of big corporations. I just think we've gone way too far that way. And this is a model to say, yeah, let's bring back a more diverse array of smaller scale economic enterprises within our communities and our regions. It'll boost our resiliency, it'll boost our stability, and it'll dramatically lower our entropic costs. And it'll have huge environmental savings as well. I think self-organization really justifies that. Now, luckily, here in New England, that is happening in the food sector. In Vermont, where we lived until just a couple of years ago, I remember in the 90s, the agricultural sector was losing more ground in the economy than any other sector in that state. And now it is probably one of the most robust sectors of the Vermont economy. Today, Vermont has more CSAs than any other state. I think they're up to 1,600 CSAs, community-supported farms. Today, Vermont is rivaling France as one of the premier cheesemakers in the world. And this has all been a resurgence that's happened within about 20 years because the large homogeneous dairy farms failed, and what took their place were small, specialized farms. And not only that, some of these farms are now linking up to create networks that are mutually beneficial. So for example, in the town of Westminster, Vermont, where we moved from, there were two produce growers, organic produce growers, who were competing in their CSAs. And one day they got together for lunch and they said, your soils are really good for growing this and this and this. These soils over in my farm are good for growing this and this and this. Why don't you specialize in that stuff? I'll specialize in this stuff, and then we'll combine it into one CSA. And they did that, and their profitability went up. But not only that, since then, they've got an organic dairy farm involved, an organic meat grower, and an organic baker. So you have four different farms and one baker. They're all independent, but they work together in one CSA, and their profitability has gone up because they've forged this network of mutually beneficial interactions. And now the manure from the dairy farms went to the organic growers, and it's just a wonderful model that's starting to mimic how nature's always done it. I don't believe we have to reinvent the wheel. Life has been on this planet 3.8 billion years. That is an incredible long time. Very hard to wrap your head around how long 3.8 billion years is, but let me give it a sort of an analogy to help you visualize it. Imagine a sheet of paper, the thickness of a sheet of paper representing a century. The question would be, how tall of a stack of paper would we need to represent 3.8 billion years? And the answer is we'd need a stack that's about 3.5 miles high. Each sheet representing a century. to 3.5 miles. Now, during that time, nature has not just sustained itself, it's thrived. And it's done it because of self-organization, creating systems that are resilient, stable, energy efficient, and it does that by building up diversity and creating this incredible network of reciprocal, mutualistic, beneficial interactions. And so I think it's a really, really glorious model, and one that we have turned away from and we've got to turn back to. And a lot of this stuff, I mean, it can be very daunting when we're talking about climate change, and you know, it's daunting. But I think the key is that we have to start with our own selves, our own communities, build these relationships, and just as was pointed out, have them start building out and get more and more, which could be called messy, but I just call complex sort of networks of relationships that are mutually beneficial. So I think I'll just stop there, and I think there's some time for questions or comments. Yes?
Do you know about Mondragon? M-O-N-D-R-A-G-O-N.
I do not know about that, no.
Spain.
Spain,
Right.
all right?
Vast region of Spain. My opinion, for what it's worth, if anybody knows of something better, please one-up me. I would love to be one-up. But to my mind, they are exactly what you're talking about.
Mhm.
They started out as one little co-op, cut to the chase. They're now over 100 co-ops employing over 75,000 people. They have enormously raised the standard of living of their entire area. They are founded exactly along the lines you were just talking about. They have their own healthcare system, their own education system, their own retirement system. In the entire history of the cooperatives from 1955 to now, and if anybody's got internet access, just put in M-O-N-D-R-A-G-O-N, should come right up on
Very
the
cool.
search engine. Okay, they have never, ever laid off a single person in the entire history of the co-ops.
Nice.
They are a wonderful demonstration, living, breathing, real, this is not theory,
Right.
of how businesses can be magnificent. Really, really good for everybody involved along the lines you were saying.
Very cool. Yes?
I wonder if you
Can we
might
just, if you're gonna ask questions, could you come down and use the microphone? So everybody can hear you and it's also being recorded. Maybe if people want to ask questions, you could just kind of.
I was wondering if you might,
Either that or hold it real close to your mouth.
Yeah. Yeah, it's working, just, I'll turn up a little.
I'm wondering if you would comment on invasive species.
Lori, hold it
Okay.
close to your mouth.
I'll repeat it.
Okay. Wondering if you might comment on invasive species and how we might go about controlling them.
Okay. So the question is, what about invasive species and controlling them? So invasive species are an example of bringing organisms from one part of the world and creating these young ecological interactions. I think with invasive species, they're here to stay. We're not going to get rid of them. And so I think it's sort of like thinking about triage. I think we have an ethical obligation to ferry our current native species through this bottleneck we're coming into. And the bottleneck that we're getting into is from the combined results of not just invasive species, but exotic pathogens that have come into our ecosystems, climate change, and I think probably new development pressures we're going to see. Because I think one thing climate change is going to do is going to make it become pretty obvious that very large areas in the south and out west are not going to become livable. And where people want to go, they're going to come back northward. So we have a period of a number of centuries here where we're going to have to get through this bottleneck to deal with these various issues. And I think that means we have to be like Noah. We've got to ferry our current species through while dealing with them. So with invasives, I think of it as triage. We make sure we keep them out of really unique ecosystems or ecosystems that have rare and endangered species, so we can maintain our current biota. We can then put our attention after doing that into areas where maybe they're just starting to invade and they're easy to deal with, they take very little energy. But there's going to be a lot of areas we're going to have to let go. And that might not sound great, but that's where coevolution is going to do its work. Basically, 3 million years ago, North America and South America became connected by the Isthmus of Panama. Those two continents have been separated for hundreds of millions of years. They became reconnected, and there was a mass migration of North American species down to South America, South American species into North America. It must not have been a very pretty scene, because it had been like all these, quote, invasives and pathogens coming in. But now, 3 million years later, those South American species we have up here in our North American ecosystems are functional members. And our North American species are functional members down there. So I'm confident that nature will work this all out. We've just got to be vigilant in getting through this process.
Not use herbicides.
I'll talk loud. If the mic suddenly comes in, tell me to tone it down. Oh, it's good? Okay. Okay, had a question, and you alluded to from ecological or biological thing to sociological or business orientation. I wonder if either you could comment or quote work that's being done on what I get worried about is the gig economy and temporary contract work. At least I see an awful lot of energy inefficiency that is a drag on the economy, that when people were employed, they didn't have to spend all this time marketing their services and could spend it working. And now with all the big things, there's a lot more inefficiency. And I'm wondering, A, do you see it? B, can you comment on it? And B, is there other work being done looking at that? Because I worry about it.
Yeah, well, it's a good question. It's certainly not my area of expertise. But it makes me think about, you know, my father, that he came out of college in the 40s, 1940s. He got hooked up with a business. He worked for that business throughout his life. He had a pension and everything else, and, you know, benefits and whatever else. That sort of a relationship, work relationship, is really becoming rare nowadays. And what businesses lose is they lose a lot of experience that, you know, was developed by having people that have been there for a long time and really developed that experience level. So I think it's a part of the problem we're seeing with the way our whole economic system has developed, is this is just another outcome of it. I don't know the answer to that, except again, I think it's probably revitalizing economies by regionalizing them, relocalizing them. I know that a lot of the small businesses that I take my Principles of Sustainability class to are remarkable. One that is really an interesting one to go to is called Badger Balm over in Gilsum, New Hampshire. Started by a guy, Bill White, who was a carpenter, and during the winter, his hands, the skin would crack open. So he started making his own sort of salves out of beeswax and olive oil and spices and herbs and things. And it was really good. And a lot of people started asking to make it for them. And so he's built that business up now that started in his garage with just him to a business of about 100 people. But the mission of his business is to create a product that's so beneficial you can eat it. So all of his sunblocks, his balms are made with basically food items, so they're edible and they're organic. But the other thing was that he said, not only making something that's going to be really good for you, but we're going to put love into it, and love is going to be the basis of my business. And so it's really interesting the way the workers are treated there. And when a position opens up, there are hundreds and hundreds of applications as they want to be there. First of all, he doesn't have sick days, he has wellness days. And he says, you know, we got the capacity here, we can cover. If you need time off, you want to go see that Red Sox game, go. We'll cover for you. The other thing he did, he encouraged all young mothers to bring their infants in to work with them until they were, I think, 9 months old. And then he has an infant toddler program in preschool right next door that is associated with the business, so they can get daycare there for free. He has bi-weekly meetings where every, I guess, month, all the members can sit in those meetings and be involved in the decision-making. So it rotates through. So his leadership and decision-making structure is very horizontal. It's an amazing thing. And he also has a full-time organic chef there that makes lunch every day for all 100 employees. And everyone has to stop work for 1 hour and 15 minutes. They can't bring down cell phones or any electronic devices. They sit at tables, like 12 people to a table. And the thing is, he says, yes, if you look at it, this ups my operating cost. But he says, but still, it makes me more profitable. Because I got people who just are going to work here, they want to work here, they learn the various things, they get worked through the different jobs, and it creates a very, very resilient place, and a place that everyone just likes to go. And he's done the same thing. He says, we've gotten up to about 100 people now. I don't want to get bigger because I'm going to lose what we even have. And so if we are going to get bigger, I'm going to teach someone else how to make another business similar to it and start it somewhere else. So it's a great, great model. But I don't know if I addressed your question, but I think looking, and you're right, I think there is an inefficiency of people having all sorts of part-time work, looking for work, not being plugged in to the capacity they could be plugged in, and it certainly is, I think, an outcome of our system that didn't used to be like that.
You get it real close.
Real close. Good? Okay. So I think everything that you said has been really, really compelling. I'm wondering if you could speak a little bit more about species evolving to a place of dysfunction in the sense of stepping outside of mutual beneficial relationships with their ecosystems, because I think that's what describes humans at this stage. There's the conventional view of humans as being outside of nature, the dichotomy between humans and conforming to nature, all this stuff, where in fact we're part of nature, and I see us as a species that has evolved to a place of dysfunction.
Yeah.
I'm wondering if you could address that.
Sure. So I don't know if there's a common view. There's certainly a view in our culture of people not being a part of nature. But I think, modern Homo sapiens has been on the planet for 200,000 years. For 90% of that time, all people lived in gathering and hunting cultures. And they saw themselves as completely apart from the natural world, completely enmeshed in it and sharing it with all the other organisms. So I think this idea that we're not a part of nature is a very recent cultural framing that we have. And I think at its core is what's caused us to be dysfunctional, because we don't see how we fit into the system and how it benefits us. We somehow think that it's something out there, and we can just keep going our merry way doing what we're doing, and technology is always going to save us. Well, it's worked for 100, 150 years. I'm not convinced it's going to work for the rest of the century. I think the burden will be too great. So we either have to start changing ourselves to become more a part of these systems, working with them, or we'll be forced to change. Nature will make us change. It's not a question of whether we'll change or not. We'll change, but it's whether we'll do it voluntarily or we'll be dragged by our feet to do it. The only time species, again, in the natural world seem to become dysfunctional is when they're moved out of their ecosystems where they've co-evolved. Is in them, they've worked in that network of really beneficial relationships. Once they're removed, those relationships are gone, and then they're not really functional until that builds up again. And I would say that sort of our cultural paradigm is what caused this for us, at least in this culture.
Regarding what you mentioned about the American chestnut trees, you said that there's a couple of patches of.
Hold your microphone.
You said that there's a couple patches of fungus-resistant
trees that you found in southwestern Massachusetts. Have you considered accelerating that process and just getting a network of people to, digging up, maybe half of the saplings that fall and giving them to giving them to people to take them elsewhere in the state?
Yeah. So in terms of those chestnuts, yes, both the state and the Chestnut Foundation have all been alerted, and we're not removing plants from those sites, but nuts are being gathered and plantations are being grown in other areas. So yes, that is happening. Yeah.
So I can think of maybe 10 people right off the bat who would enjoy, who would love to just grab some of the nuts and plant them in the forest around their house, around their neighborhoods.
Oh yeah.
Join Massachusetts chapter of the American Chestnut Foundation.
Thank you. Complexity kind of reminds me of a glass prism. The amazing thing about it is there's so many different sides to it, so many different ways of looking at it, so many different colors and whatnot. So the current movement towards moving energy off of fossil fuels onto the electric grid and then greening the electric grid, does that fit into the principles of nature that you've been pointing out to us today, or is that contrary?
Well, it really depends how it happens. So whenever we're looking like at an energy resource, you want to look at it in a couple different ways. One thing you want to look at is how much energy return do you get out of that resource for the energy investment you put into it. Because the greater return means the less relational entropic cost. So, for example, when petroleum was first being brought out of the ground, you were getting about 110 units of energy for about every unit of energy being invested to get that petroleum. Now we're down to about 12 to 14 units for every 1 unit invested. So what you want to do is you want to look at technologies that can get you a bigger return for your energy investment, because there's always going to be entropic cost. But the other thing that self-organization would say is we got to decentralize our energy systems. That having big, expansive grids for putting energy through them great distances is not a great thing, because the further you have to transport, let's say, electricity through a grid, the more energy loss you get. And again, the higher entropic costs are, because you need to generate more of it and whatever else. A study was done by the U.S. government, by the military actually, back probably about 2012. And what they were looking at was if Iraq, if they hadn't gone the way of going the traditional way of building up, maintaining the big power plants in the grid, and instead they invested the money in just putting solar panels on all the buildings down there, they found out for the same cost they could have gotten the same pretty much electric generation, and it would have been much more resilient, because the decentralized method meant that insurgents couldn't start blowing up infrastructure and stuff. So I think we got to be wise about this. There's no silver bullet. It's like looking at the best types of technologies and also thinking about decentralizing. I don't know what's going on in Puerto Rico right now, but golly, I hope that they're not just rebuilding the same thing they had, because that is not, as you can see, a resilient system.
Just as a quick follow-up, I agree that the idea of decentralizing, fits the natural model, but at the same time, that connectedness, even if it's decentralized, the fact that it's connected.
Exactly, and that's the key. It's not that they're decentralized and isolated. They're decentralized, but there's a connection. And for example, we just don't want diversity. We want networked and integrated diversity. So, I love going down the Arnold Arboretum and seeing all these wonderful different species of trees, but when I go there, I'm looking at a mixture. That is not an integrated system, because those species haven't co-evolved it all together. We can go into our forest that might only have 15 species of trees, and it's going to be a much more robust system because of all that networking. So, self-organization has two pieces. You enhance the diversity, but you network it, so you get the full power and advantage of all that relationality.
Hi. I have a question specifically related to resilience as it applies to nature. So environmental resilience, I can't pull a definition out of my head, but it would go something like the ability of natural systems to protect us against extreme events, disturbances such as drought and insect explosions and storms and so forth, and then for the system to be able to refine its equilibrium and bounce back. And I'm wondering from that perspective, if you could give us maybe some of the top things you believe we could be doing right now, right here in our own, cities, towns, whatever, that might have the opportunity to build that resilience so that we, we're losing it, but how can we maintain it?
Well, again, there's no silver bullets. I don't know if there's, it depends on what you're looking at. One of the big things we could do, certainly in a place like New England, is really looking at our farming practices. What's being shown now is that the biggest sort of contributor to sort of climate change and greenhouse gas emissions is agriculture, both from removal of complex ecosystems, which can be energy sinks, as well as bleeding off huge amounts of carbon in the whole process. So, and one way to do that is to start, another friend of mine who also is here in Massachusetts is Ricky Brook at Seeds of Solidarity Farm over in Orange, Mass. And when he got that farm 20 years ago, it was just a wooded parcel with about a half an acre area that was shrubby. That was the yarding area that before the property was sold, the last logging took place. They brought all the logs down there so the log trucks would pick them up. So he bought this property and said, I'm going to start my vegetable gardens here. But he didn't want to disturb the soil in any way, shape, or form. He didn't want to till it all. So he said, all right, I'm going to go in there and clip down all those shrubs. And then he's thinking, like, how do I kill that stuff off so I can plant into it? And he was thinking he was going to cover it in black plastic, and he didn't like that idea. And he was driving through Orange, and he drove by the bedroom factory and saw huge stacks of cardboard. He thought, God, I wonder if I just took that cardboard and after clipping everything, laid it down and put some mulch hay on top of it, if that would do the trick. And sure enough, it did. It killed off all the vegetation. Within a month, he could cut holes through the cardboard. He scooped out little bits of the earth that was there, put compost in, and started planting. 20 years later, his soils have never been touched. The University of Massachusetts has been monitoring them and studying them. They're thinking they're the most fertile agricultural soils in the state. And he's getting huge amount of produce off of them. Because what's happened is allowing those soils to develop, they've built up all this biodiversity that would have been destroyed through all those tillings. They've sequestered carbon. They've got these magnificent mycorrhizal networks. They're holding nutrients. It's at the point now where he's not even adding nutrients to his soils anymore because they hold it so well. So it's a really good model right there. Now, in terms of natural ecosystems, we don't have to do that. There's nowhere in nature is the soil turned over every year. But I think it's, again, being vigilant. We've got to, if we have really unique, unusual ecosystems, try to keep invasives from getting in if they're not in there yet. Like I said, other areas we let go. We need to try to keep our systems as species rich as they can be with our native species, because that's going to be a big part of the resiliency. And, we're going to get range expansion. So we could even start thinking about taking plants that are just a little bit south of our current range and bringing them up. They'll be co-evolved, because they've already co-evolved with other species that are up here that are from down there, and that can also possibly be a help as well.
Repeat name of farm.
Oh, Seeds of Solidarity Farm. Now, by the way, I'll just tell you, they do an open house 3 times a year because they don't want people traipsing into the little farm. It's only like a 2-acre farm, and that's where they live. But they do 3 times a year a open house. So they will tour people through the farm and explain all their practices.
Thank you. Just as follow-up, there's disagreement with what you're saying, but I wanted to point out to the audience that in our country, in the U.S., the biggest agricultural sector is lawns.
Yeah, it's a big
And
one.
so we may be able to point to farming and
Yeah.
say they should be doing this, but we also need to look toward what we're doing on our own properties, public properties and whatever, and take similar measures.
Yeah, there's one whole community neighborhood down outside the University of Pennsylvania where they all agreed to get rid of lawns and just put in vegetable gardens. So, yeah. I think we have time for one more. I know I'm supposed to end at 11, so.
Actually, I would like to intervene if I could.
Oh, yeah.
I would just like to recognize
Microphone, John.
sorry, there's a young person waiting to ask a question. We haven't had enough questions from young people. I'd like to ask her to step forward and ask a question.
All right.
Can I just say one thing? Ricky and Deb's farm hosts the Seeds of Solidarity, the Garlic and Arts Festival in September. So you can Google that and come to that. And I just wanted to let you know that Mass Forest Rescue has literature over there. I'm very grateful for your system's approach to things, but I'm very concerned about the forests that are getting shipped off to Canada to be milled for pellets and lumber because they subsidize the wood products industries, and all of our forests are getting cut down daily. Our watersheds are and in South America, the Woods Hole Research Center has found that this process of high grading and degrading forests is now causing this rainforest to be a carbon emitter. How can we prevent that in Massachusetts and New England?
Yeah, well, so a couple things. One, I'm part of a group of forest ecologists that are really pushing state agencies to be sure that state forests and stuff, that at least 10% of those holdings are left unmanaged, so they can accrue old growth status. We really believe that we need about at least 10% of our forest getting old growth status. So that's one thing. The other thing is that, again, here's where relocalization, re-regionalization can really be of help. We used to have a lot of sawmills throughout New England. They've dwindled dramatically. In place of them, we have these really large ones where the logs are shipped hundreds of miles to, instead of just being shipped 5 to 10 miles from a woodlot. Our best management strategies for our forests, I mean, it's a resource we can use, it's a renewable resource, but it's the sort of thing where we ought to be doing probably single tree selection, where we're not creating huge gaps. Because when you create huge canopy gaps, all that carbon that's in the ground, it goes right out. So if we really want our forests to be carbon sinks and really resilient, it's by not having large-scale invasions into them via logging. Now, one thing I should mention is, one of my colleagues, a soil scientist, says we got to be careful about above ground bias. And she's always telling me this. So and I've learned it. And that is that, we think biotic diversity, we're looking at, well, how many different species of trees or wildflowers or birds or whatever. Well, once a forest ground area gets to be about 80 years of age, the bulk of the biotic diversity is down in the soil. It's not seen. Incredible biotic diversity down there, and it only accrues as a forest ages. So I think we can sustainably extract timber resources. It's one of the gifts we have in this region, but we got to do it in a way that's, I think, a bit more conservative than we have been, so we can make these forests really be resilient and really be carbon sinks. But I guess last question.
Hi, I'm an undergrad at Tufts, and I just want to say thank you so much for speaking. I'm here with a few classmates, and your book, Creating the Forested Landscape, has been one of the highlights of our environmental fieldwork class, so
cool.
Thank you so much for that. My question as a fellow Vermonter is about, I saw in the news recently that there's been many farms, or dairy farms specifically in Vermont, that have been closing, and there's been hundreds of cows that have been auctioned off, and it seems like small independent dairy farms in Vermont are definitely facing a lot of challenges right now. And I know that you're talking about different CSAs coming together and working on independent, sustainable farming. So obviously there's a lot of hope in that area, but with these recent challenges in Vermont and with growing urbanization, how can we continue to feed populations sustainably, and how can we overcome these challenges in the realm of sustainable agriculture?
Yeah, so I mean, it's true. I mean, in Vermont, dairies are still having a very hard time. That'd be quite big. I mean, to be profitable, you got to have a farm that's going to have at least probably nowadays 1,000 milking cows. And that means when you get that scale now, it's hard to get them out into pastures. They're often, you know, in their barn stalls and stanchions pretty much throughout the day. It's not a great model. And that again is because so much of what has happened has been so concentrated that it's very hard for these smaller farms, especially dairies, to compete. You know, you'll often hear that we've got to continue doing large-scale industrial agriculture. It's the only way we can feed ourselves. I don't think that's true. Ricky's farm has produced more produce per acre than any other farm in Mass. But what it means is you need a lot of farmers. I guess it was back in 2008, diesel prices went up to the point where they're around $5 a gallon. And all the farmers that had laughed at Ricky Bruck when he first started doing his no-till, because he thought he was crazy, streamed up to his farm and said, Ricky, help us, we can't afford to plant because you're going to lose money if we plant because the way all the diesel fuel we're going to use. And Ricky just looked at him and said, I can't help you, you're too big. And the key was, he can do it because he's small. So I think, again, it's a great model of decentralization. Smaller farms can be profitable and can do good work and be very productive, but it has to be a smaller scale. Ricky, for example, doesn't use any petrochemicals at all on his farm. It's all the amount of calories he uses is probably 1,000 kilocalories of his own body energy a day, and that is it. And yet, very productive. But it looks like we have one more or not.
No, I think that's it.
Okay, I guess that's it. I'm sorry. All right, one more. All right, one more.
It's a Cambridge City Council.
All right. All right, last one, really, for the first really last one.
Political privilege. I wonder if you could unpack the role of competition a little bit. I was reading an article just this morning about how our brain circuits are affected by stress, and we end up making more high-risk, high-reward decisions than when we're not stressed.
Mm-hmm.
And humans have been living, as you said, in small hunter-gatherer groups, but they've also been living in intense competition with each other, invented warfare, invented armies and empires, which have led us to this point of overconsumption and dysfunction. So how can we undo some of that competition that is really driving the dysfunction?
Yeah, well, I think, again, I think nature has a good model. In nature, competition does generate innovation, but it's innovation focused on coexistence. So you specialize, you find your niche, and you network. While we see often, like in our culture, competition is to win. And it isn't about networking. It's about, if you're in the economic sector, it's about competitive exclusion, getting rid of the competitors. It's not a model that I think is sustainable. I think nature's model is, yes, competition can create innovation, but the innovation is how we can specialize and network and coexist. So, thank you.